Welcome to a new test and teardown video. This time it's another radiometer. And this is an HO32C. I spent quite a lot of time trying to clean this up, so it's a little bit presentable for the video. I mean, it's still not super nice. It just keeps coloring all my towels yellow, and it just keeps doing that. So I need to clean it up a lot more. So this beat frequency oscillator, the design is from 1961, and it consists of two oscillators, and they are individual oscillators running at about 200 kilohertz, and then they are mixed together, and then there is a low pass filter, and then the output from the low pass filter is amplified and driving the outputs, and also driving this indicator bulb or a valve. So this output here is not from zero, obviously, right? It's from 200 to 220 kilohertz, and the other one is also from 200 to 205, or is it? I think it's actually the other way around, right? So here it's 200, and then it goes actually down. But the main idea is they are added together and then filtered. When I got this unit, I had the top. Hang on a second. I had the top here with 4 notes about all sorts of errors, but they were in a really bad shape, so I had to remove them and trying to clean this up. And then I could see this is the original calibration sticker from 1973. And we actually got 2 stickers on top of each other. So that means it went to calibration 2 times. All specifications. Fantastic, in 1973. So yeah, this unit is definitely a lot older than that. Probably a few years older. But the main design is from 1961, and this is the C model. So that is obviously after 61, but the schematic is from 61 I could find at peel.dk. I will, of course, link to the manual, including schematic, in the description, so you can enjoy all the full details about this unit. But because of all those error notes, I am forced to opening this before I power it up, because I really don't want to blow it up. So I really need to just a visual inspection before I power it up. Oh yeah, about zeroing adjustment, obviously, because the 2 oscillators, they can beat together to create the output. One of them you can fine tune. So that means if you set this for 0 and you set this for 0, then you fine tune until you get 0 output. So the idea is the output frequency drives this meter, so you'll see a pulsing, a low frequency pulsing, because it actually does go to 0 hertz, the difference, right? And then you know the 2 indicators here, they're correct. So that is more or less how it is, and then all the output terminals and the different from millivolts to volts and all that kind of stuff. You can select different impedance for outputs. So that is going to be quite interesting to see if there is any output at all. If we are that lucky, I would be surprised. But let's go inside. Now I am inside. That was quite easy. I actually see a lot of adjustments. This is the bottom of the unit. And we see distortion and line impedance. And that's those 2 potmeters here. After a little bit of inspection, let me put down the cabinet, but it's looking quite all right visually. It's in quite good shape. I don't see any dark, burned, blown up components. I don't see any rusty, bad things that is scary or anything, so that's probably the two inductors used for the two oscillators, and that will be the zero adjustment. Look at that. The capacitor here is just really fine tuning. So I bet we have to set this in center and then perform tuning on all sorts of other methods when we're inside here, right? So otherwise we can't compensate for any drift. Let's flip it a little bit around. Oh, it's quite heavy right here. That's probably the, yeah, that must be the output transformer. Oh, we got the mains, power supply, rectifier, and another rectifier. Mains switch. Oops. And that is the top where all the dust is collected. I mean, look at that detail. We're parallel to capacitors in this one. That's what I think. So that means the other part of that capacitor got to be chassis. But it looks like it's isolated. Well. That is not original. That is supposed to be... No. Look at that. And they're supposed to go outside. Like that. So this is not the right one. It wasn't really correct. But luckily I got new ones so I can fix that. Got a little bit of corrosion outside that tube. This can't be good. That is moisture ruining the text, but not really. We got... Oh, this is not good. We had water going into this unit, yeah. Ooh. That will be the two oscillators. I mean, it's alright. Yeah, let's power it up and see what happens. So we're ready to first power up. Scope is connected. Mains is connected. This is powered on here. I'm actually going to turn on my variable and crank it up. Okay, 8 watts at 80-90 volts. I can easily crank this up. There's nothing to be afraid of here. 150 volts and 30 watts, and then we just go all the way to 220. So that was a nice and smooth start. We are now at 220 volts and 50 watts. There is no output. Oh, we got light in that one, yay! But I see no... Oh yeah, I see output. I see output. Yay. Look at that. What is that? That is output. Ooh. What I also see is ripple. Look at that. That will be mains ripple. But anyway, 1.5 kilohertz. Is that right? Is it? Yes, it is definitely responding to that one. So if we put this for 0, and then it's responding to both of them. Lucky, both oscillators are indeed running. And if I crank this down to 0, oh, look at that. 0, 0. And then we got 100 hertz. I could probably try and poke around with this 0, but oh, look at that. So the 0 knob also works. Oh, look at that. The indicator here is actually responding quite well to the 0. I don't know if you can see this, but there's a modulation here. And then this is the... Okay, this pot definitely needs cleaning. So that is what I need to play around with. But that is now in 0. So that is beating. So if I go to now 1 kilohertz here. Oi, oi, oi. 1 kilohertz output. How cool is that? So we go back to beat 0. Let's play with the other one. And set this for 100. Oh, yay, yay, yay. Lucky. But I mean, so far all I can see is a lot of ripple, and that is what is the problem so far. And let's crank this all the way up to 515. So this one goes a little bit on the high side. And there's probably some alignment instructions and all that kind of stuff, but all I care about is how much is not working. But yeah, 314, yes, this is a little bit on the high side. You could probably also just do this and then crank it. No, you cannot. Oh, then it goes all the way back again. This 0 was supposed to be in the middle here, right? Like that, but... And this pot, so... Oh, look at the output pot. It's just bad. So let's try and fix that. And then... Aha, this is how it works. You select the different outputs, and I am between 1 and 3. That is that output. Right? So what if I... Then there's no output. Funny. Okay, well. Interesting. Oh, I forgot to show a little proof of my pot meter cleaning techniques. I don't know if you can remember earlier in the video how bad this pot meter was working. Look at this, is magic. Yeah, that's just how it is now. The only thing, well, this is how it is supposed to be. This indicator has nothing to do with the output. It is only for the beat frequency to adjust the two oscillators to 0 and to see they're now calibrated. That's the only thing this one is for. As far as I can see, even on the schematic, it's easy to see the output, and all that is after the rectifier and that meter, by the way. So that's how it is. I wanted to show you a little bit more details of the internals. The two inductors for the two oscillators, and one oscillator here is working from 179 to 200, and that is 200 to 200.5, and that is indeed the two oscillators and the mixer. And after the mixer, the output goes to a low pass filter, and it's actually not that easy to see, but it's those three inductors, or whatever you want to call them, they're in here, inductors and capacitors and all that kind of stuff. So that's a low pass filter that works from 0 to 200. Well, it's obviously going to cut away 200 super duper nice and clear, because the output frequency of this unit is 0 to 200 to 20. So I'm done with my first round of inspections and a little bit of measuring around. I'm doing a little bit of DC measuring on the capacitors here. 280 and 263. We got some resistors in between here, and then resistors again, and then resistors again. And this is a very good design with all the resistors that's used for filtration and voltage dropping and all that kind of stuff. Is located far away from the capacitors, so it's not heating up. So they're not heating up capacitors, right? Because hot capacitors, they don't last that long. And I believe this capacitor and that capacitor, they're in a feedback system with the output tube and the output transformer and all that kind of stuff. And that capacitor is a filament. So we've got 17 volts of DC on that one, and quite on, I think it's a half a volt of a ripple on that one. So I think that is normal. But that capacitor here is, as I said, in the feedback kind of system. But look at that capacitor, how bad it looks. I mean, this is not good. Some of the good stuff is leaked. So I think that is going to be the one I will start to attack. And somebody also put this little arrow here, so that means they want me to look at that, I guess. We got quite a lot of DC on that one. It's 220 microfarads in parallel. So let's see if I can find something around that area. Ooh, I really need to remember to pull that. And then I will see if that is the problem. I've been playing a little bit around with all the different capacitors and changing capacitors to others. There's a capacitor that was over here. Look at that. I mean, the acid just totally damaged the capacitors. So that's really bad. But it also came to my mind the selenium rectifier. That one for the high voltage. That is not working at all. High voltage is also very low, but there's a lot of ripple. So why is there a lot of ripple no matter what I do, right? It's because not all of the 4 diode sets work. There's a very big difference in the forward voltage and forward current in this rectifier. And that, of course, leads to a lot of ripple. So, I really want to end and conclude this video. As you can see here, this is getting quite funny. I've been replacing capacitors, adjusting series resistor for their filament voltage. That capacitor there is replaced right here. I don't know if that is easily visible. Here we go. I didn't replace the 2 large ones, but that high voltage capacitor here I replaced. This one up here should be replaced. I did not do that. I actually see quite a lot of corrosion here, but it actually seems to be working. So I just left it because I was lazy. That pot meter, I cracked the rear plate off here and then cleaned it with alcohol, and now it runs super smooth and stable, and my output is super nice and variable. Ha! That is really good. And both of my rectifiers, they're now replaced because they were absolutely bad, both of them. So now they're silicium rectifiers. But of course, now my voltage, both my high voltage and my filament voltage that's like way too high. So I actually cut this little wire. There was a wire here between one end to this variable part, but I just used the entire length of that resistor for the high voltage to get that one in. And I did the same with the filament voltage. As you can see here, I removed the red wire all the way to the end, and I cranked the voltage dial to 240, and I only input 230. So this lowered all the voltages and made it all stable. And then playing with the adjustments in here and the output level, now it is a nice stable sine wave, and there's no ripple or anything else. The only thing that I was a little bit lazy to figure out was the zero adjustment. So zero adjustment is still all the way to the end here. I would have preferred this to be in the middle. I would expect it's possible to trim one of the main resonators. So then the sensors should of course be here in the middle, right? But yeah, to get into the screw for the rectifier, I had to remove that one. So now it's all clean up, reassembly, and then call it a day. Whoa, that was a big, tough one. So, all right, thank you very much for watching, and see you again tomorrow. Bye bye.